Excellent. I'm Dave Poggle. I'm a founding member of the Duluth Climbers Coalition. I'm also part of the planning committee for this event, and I want to welcome you to our afternoon sessions for the Great Lakes Outdoor Summit. Well, here we are on a balmy late October afternoon, just what we might expect during what is shaping up to be the warmest year on record, again. Clearly, climate change is much on our minds as outdoor recreational people. The products of weather, snow, ice, wind, rain, sunshine are essential to myriad forms of outdoor recreation and industry. But these also depend upon what we have come to think of as seasonable amounts and at seasonable times of the year. And more, it seems seasonable is a word of shifting context. In the next hour, we will hear from two amazing experts who will lay it out for us, what we may or may not be able to depend upon in terms of our climate, and how we might cope with what nature will or will not be serving up. Please join me in welcoming Kenny Blumenfeld, Senior Climatologist for the Minnesota Department of Natural Resources, to be followed by Katie Frerker, Climate Adaptation Specialist for the Northern Institute of Applied Climate Science.
Hello, two scientists. So we have a lot of information to share with you, so I apologize. I'm gonna go quickly through. There's some deep stuff we're gonna get into, and I wanna know a little about you. So my first slide, I'm not gonna say anything about it. I like being outside too. We're kindred spirits. Who here's a cross-country skier? Oh my gosh, it's almost everyone. Okay, downhill. All right, winter biking. Yeah, all right. Kayaking. Some of you are like everything. Climbing. All right. Ice skating. Just camping. Hiking. Okay, this room's amazing. All right. It's great to be up here with people who are, I think, in many ways like-minded. I've got my timer on so that I don't babble too long. The purpose today is we're going to discuss our changing climate in Minnesota. And some of this is valid for the region around Minnesota too. We're going to emphasize the recent switches between extremes. That's going to come out naturally. The long-term warming and moistening of our climate. So these are the long-term trends. So we have extremes. And then we also have trends. The kind of normal ups and downs that remain part of our climate. And then I'm going to talk about, because you know, the dry conditions have freaked a lot of people out. And I'm going to talk about how the dry period that we're in right now, the early 2020s, actually shows evidence of a continued wet trend. And because I'm a state employee, I have this enterprise access to all of the stock photos that come with the Microsoft. And we don't use them enough. And so I thought that's the face I would make if I weren't a climatologist and someone said, all this dryness shows us how wet it's become. But I'm going to hopefully make that point for you. So first, let's just go back. Last winter for winter recreation was devastating, right? I mean, it really was. And it kind of began in November. We ran out of precipitation again after a pretty good fall. And then the temperatures just started ticking upward. And we got into December, and we ran into one of the most unbelievable anomalies of my career. Well, no, probably the singular greatest temperature anomaly of my career. And really of your lifetime and anyone who you've ever known or been related to's lifetime. And you could just take the modern history of Minnesota and say this was the warmest December, the biggest temperature anomaly on record during that entire period. December also wasn't confined to Minnesota. You can see this was a regional event. This map shows temperature anomalies, so that's the difference between what we observed and what would have been normal. And you can actually see Minnesota is sort of on the edge of the heart of this anomaly. It was weirder in northern, not necessarily warmer, but warmer relative to what would have been normal in the Hudson Bay area, northern Manitoba, the northern prairie provinces. Wild. Just to kind of put it in perspective, here's all of the December temperatures that we have on a homogenized data set back to 1895 in Minnesota, and there's some really warm Decembers in there. There's actually already a trend. And then we got to last December, and you know, people always say it was off the charts, and that's an overused term. But if we just graphed everything up through December of 2022, then there would have been no reason to bring this graph up to the axis up to 30 degrees Fahrenheit. And what we measured last year was off the charts relative to that. And then it just flipped. And I can tell you the date it flipped was March 20th. In some parts of the state, it was March 21st. We actually had a 34-day dry spell in the Twin Cities, and in some parts of the state it was more, in some parts of the state it was less, but it began on February 15th, 16th, ended about March 20th. And from that point on, we just got wet, wet, wet. You can't see this map. I don't need you to scrutinize it. It's basically a composite image showing all the precipitation that accumulated not far from here in St. Louis and Cook counties during one afternoon in June this year, where ended up getting 5, 6, 7, 8 inches of rain around Lake Vermilion, around Tower. It was an unbelievable amount of rain, catastrophic flooding, and I believe it was Cook. It was a difficult time. And this map, and please don't read this, but the map is a percentile map, taking all of the precipitation from April 1, really kind of near the beginning of that wet period, right up through the middle of August, and comparing what we measured at that time with the historical record and ranking it in percentiles. So, you know, if you're low percentile, it's really dry, and if you're high percentile, it's really wet. And we were all top. Southern Minnesota was top of the charts. Northeast Minnesota, near the lake, in Lake Cook and parts of St. Louis County, also top, 99 percentile, meaning A+, best in class, although worst, although honestly, well, one of the things we can talk about is how that gave us a little bit of protection from the drought that set in later in the summer, but we won't get into that right now. We'll see if we can make it through these slides. First, some facts about Minnesota's climate, and I can't cover everything, believe me. Any of you have seen me talk? I could go. We could do this for an hour at least, but we got other things to cover. So I'm going to try and get through the climate part here, and then Katie will give some nice pointers on how to adapt to a changing climate, and then we have a panel after that in this room that will discuss how leaders in outdoor recreation are facing the changing climate. So one is, keep in mind, we have a naturally extreme climate with a lot of variability and a lot of weather hazards. These are just examples of the hazards and the variability. Same year, blizzard, tornado. This is every year in Minnesota you get tornadoes. Every year in Minnesota you better get a blizzard. And even this last year we actually had one. Nobody remembers it because it was after the winter had already crushed everybody's spirits. But we did have a really good winter storm at the end of March. This is just a graph that you don't need to think too much about, but it just shows a climate variable. In this case, it's summer precipitation departures from 20th century averages. And what I want you to notice is you get ups and downs and ups and downs. We have trends in our climate, but we also will always have normal ups and downs that are related to, those ups and downs are mostly related to natural climate variability. The trend is not. So more facts. Human greenhouse gas emissions. They cause the global temperature to rise. I would love to go and do like a 1,000 level meteorology course right now on how greenhouse gases work. But this idea that they trap heat is mostly correct. They do a little more than trap heat. And it's not quite that simple. It has to do with their ability to absorb certain wavelengths of heat, but they do it really well. And so we when we put certain greenhouse gases in the atmosphere, all of which were naturally there anyway and already sort of provided a nice buffer against what would have been insane amounts of heating and cooling that we could not possibly withstand, by enhancing that effect, we've essentially trapped more heat. When you trap more heat, well, we should mention the greenhouse gases in the atmosphere that we've put there are the cause of almost all of the long-term warming. So if you look at that simplified graph on the right, it's just Minnesota's annual temperature. You might be able to see precipitation in the background, but look at that trend line. It's an idealized version of what's happening. Anyone who understands statistics knows that a regression trend line from ordinary least squares is one of the most basic ways of expressing a trend. It's not statistically very sophisticated, but it tells you a good story here. The slope of that line is almost entirely, about 99% of it, is due to human-caused greenhouse gases. But you see the ups and downs along the way there? Those are natural in origin. Those are little cycles in the ocean and circulation, El Niños and La Niñas and things like that. So the upward trend is generally long-term caused by us, but we're going to have these peaks and dips along the way that in many cases we have nothing to do with, or in some cases our role in them is nuanced and kind of not necessarily what you would think. More facts. When you have rising global temperatures, that means that an average place on Earth, including Minnesota, including the upper Midwest, has more access to heat and also water vapor. Now, it doesn't mean that you have access to it. Now, think about what that means. If you have access to something, then it means it's possible for you to obtain it. It doesn't mean that you always will have it. The reason gets down to essential thermodynamics, that when you increase the temperature, you also increase the rate of evaporation. What gets evaporated the most is our oceans. We have a huge source of water. So by raising global temperatures, we increase the rate of evaporation off of the oceans and really off of any average body water surface. That extra water goes into the atmosphere where it resides as humidity becoming the fuel for precipitating weather systems. And so we have more access to both heat and water vapor. In Minnesota, that has caused our climate to change. It's not always warmer and it's not always wetter, but we have more access to heat and water vapor, and as a result, the combined warmest and wettest years on record, the top 10, is entirely since 1998. So those red dots are all years from 1998 and beyond. Since 1998, those occupy on this graph, showing cool years on the left, warm years on the right, dry years on the bottom, wet years on the top. The ones that are combined warmest and wettest there are all in the last, 27 years. Some more facts about our climate, our temperature, our humidity, and our precipitation are all increasing in Minnesota. These are 3 different ways of looking at it. Again, I don't think we have time to dive into this, but these maps show how Minnesota's accumulated temperature changes have progressed since 1895. We've added about 3 degrees on average, more in northern Minnesota, less in southern Minnesota. It's most pronounced in the winter and at night. So winter lows, northeastern Minnesota, they're up 7+ degrees on average from where they were at the beginning of the 20th century. And summertime highs are not climbing nearly as fast, but they are climbing fastest here in northern Minnesota. That graph on the right is no surprise. You have increases in extreme precipitation. And the graph on the lower right is just showing one measure of how we actually have increased humidity in general. The highest dew point of the summer is higher than it used to be. So again, it's especially the winter and overnight temperatures, and it's increased precipitation extremes, which is actually what's driving our increased precipitation in general. In some cases, we get more days with precipitation, but what we're really seeing is when it rains, it tends to rain more, and the biggest rains are tending to be bigger. Just more, so this is the this was for nerds. who like numbers and think numerically, and this is for qualitative thinkers who say, show me a picture. What do you mean? Here's a winter warm day. I don't even know what day this was. We go outside our office, we take a picture anytime there's interesting weather. This happened about 20 times last year. They were like, it's really warm and sunny, and there's no snow on the ground. Let's take a picture. That's Gooseberry Falls, one of the recent floods. Now, summertime high temperatures in this region aren't really increasing that much yet. Here's a good station in Minnesota. But that graph on the upper, or the map on the upper right shows that there's a pipeline of intense summertime heat that is building, and you know it's coming. It's been delivered to other parts of the country and other parts of the world. Hasn't really arrived here yet, and instead our biggest change has been in winter, but that model, it's an old generation of climate models, but it was actually a really rosy scenario where countries get together and they make good policies and they reduce greenhouse gas emissions, and we really bend the curve, and it still shows an increase in the number of 90-degree days by a factor of 2 to 3 across the entire state. So there's a lot of additional heat that is being stored in the Earth's climate system that hasn't actually been delivered to us just yet. Drought is not showing an increase in frequency at this time. We're in a high frequency period, but it hasn't actually changed the long-term trend. So that's what that lower picture is. People always wonder about big, severe convective weather events like tornadoes and hail and damaging winds. And we don't see any real increase in their frequency or their severity yet. There's some research that's interesting about those derechos, the big blowdown type events. They are probably going to get at least more widespread and longer lasting as we get into the future. But it's hard to know exactly what direction they're going right now. But one thing we do know with all of these hazards is that their seasons are expanding and their geographic ranges are expanding. So here's an example of what I thought was the most remarkable weather event of 2021. It was October 10th, and a tornado went through the boundary waters into Canada, making it the farthest north latest tornado on record. So no tornado that far north had occurred that late in the year, vice versa. It was wild, and it was a big tornado. It flattened a lot of trees. That was the event of the year until this sucker hit southern Minnesota with over 20 tornadoes in the middle of December. So seasonal expansion, geographic range expansion for these severe convective weather hazards, even though the hazards themselves aren't necessarily becoming more numerous or worse. And I'm talking about hail, high winds, and tornadoes there. And then, of course, we have wildfire and air quality hazards. And these are re-emerging trends. We used to have a lot more fire, and we used to have a lot worse air quality. See, it worked. And most of these air quality hazards, I mean, we of course have urban ones from urban processes, but we're really talking about fine particles from forest fire smoke. And we've seen increases. It's not every year. You have big years and you have little years, but the fact is that our forests are under a lot of stress. And it's not just the heat and the dryness that cause fires, but there's also accumulated ecological stress that's affecting a lot of our vegetative systems from how warm things like winters have been. And so some research indicates that some of the fires in Canada in 2023 were not just drought triggered, but were also a result of accumulated hydrothermal stress. I'm not the forest expert here. That's like the extent of what I can say about forests at all. And then the degraded air quality will continue as an emerging trend because fires are generally going to be more prevalent, especially in our forest systems. And the reason I call it a re-emerging trend is because we have short memories. You know, we used to just fire everything with coal and there was soot everywhere and people couldn't breathe most of the time. So fortunately, that era is gone, but now we've got kind of a new source of poor air quality. So I am going to skip this awesome graph showing that International Falls' January low temperature is now 11 degrees warmer than it was just 6-7 decades ago, or that the lowest lows of winter are much warmer than they used to be, or that the freezing seasons have shrunken by 1 to 2 weeks across all of the region, or that the ice cover season is about 2 weeks down since 1970. I'll skip over the part where I show you the stair-stepping graph of how winter rains have increased across all of Minnesota, or the perplexing fact that winter snowfall is increasing while winter temperatures are also increasing and instances of heavy snow are increasing. And I won't dwell on the fact that that combination can be lethal to recreation resources and to our forests, as we saw in the winter of 22-23, so 2 winters ago, when we lost more trees in Minnesota than any snowstorm on record, from being crushed by the weight of heavy, wet snow that piled up a couple feet. We're going to pass it off to Katie here. So we've had a dizzying pattern of recent extremes. The main trends continue. I should go back because I showed you the cat. I just want to point out, see this is a precipitation graph showing no trend up until 1969, and then a slight, a trend of a few tenths of an inch wetter per decade on average from 1970 forward. And the ups and downs are the annual precipitation averaged across Minnesota. And these red circles are all dry periods. And I just want to point out that when you look back at all the other dry periods, the one we're in right now is the wettest on record. And so even in the drought, you see evidence of a trend towards more precipitation. Now I've connected with the promise that I made in that early slide, so I can give it over to Katie here. There's you. Fortunately, you got something better coming, so thanks a lot. We'll do questions and whatnot when Katie's done.
Cool. Thank you, Kenny. That was great. Hard act to follow. My name is Katie Frerker, and I work for the Northern Institute of Applied Climate Science. Here to talk about, so Kenny just told you, the climate things that we're witnessing in Minnesota, the trends, and kind of what we have to look forward to. And what I want to talk about is how we can actually do things on the ground to adapt to what we've learned from Kenny. I'm a Forest Service employee. I'm based in Duluth, Minnesota. I work for NIACS, Northern Institute of Applied Climate Science, and we have our organization is pretty unique. It's unique in the nation in terms it's a Forest Service run collaborative. We have a bunch of partners that are listed on the bottom of the screen, but I think, what's important to know is we have a footprint of northeastern US, so Minnesota down to Missouri and over to Maine is kind of the area that we serve. But we're not confined to working with the Forest Service. We work with all types of organizations, and we're kind of just a climate change help desk. So trying to translate climate science and information into people who are managing the lands, recreating and living and working and using the lands. Okay, one of the big things that NIACS has produced in terms of trying to help people understand and manage climate change is a framework that we call the Adaptation Workbook. I'm not gonna go through all 5 of these steps, but I do want you all to know that it's available, and I want to give you a short version of how you can maybe take a shortcut with the organizations that you work for to incorporate climate change into your decision making. And the workbook itself, it is just a framework, and so everyone, you're in unique places on the landscape. You have your own unique objectives or audiences that you serve, and so it's not a prescription on how to do this, but it's a way to guide things from big picture, overwhelming stuff down to what you can do on the ground. It's just a framework, and you get to be creative in it. The 2 steps I want to focus on today of this cycle are the 2 and the 4. So step 2 in our process is where you look at climate impacts. What do we know about the climate? What has happened? What's predicted to happen? Kenny just shared that information with us. So now, you've got step 2 covered in this workshop. The part that I want to go over today is what can we do to adapt to climate change now that we have that information in our hands. And so I'm going to focus on this step 4 of the process today. And again, I really want to emphasize that, it can be a downer to hear that climate change information that Kenny presented, and I understand that, but it means also that we have the opportunity to do something. We can take some kind of action once we're informed about the risks and the impacts that we're aware of. And so this process is important because it helps connect the dots from those really big picture, broad concepts that can seem overwhelming, and it guides you to a place where you can, on the ground, figure something out. And so Kenny just told us, he gave us a lot of information, but some of the things that always stick out for me in Minnesota, what's happening is winters are warming, right? We're getting warmer temperatures, but it's really affecting the winters most. We're having increased heavy precipitation events. There's increased flooding, and it's wetter overall. Maybe we're not getting as much snow. We're getting a lot more winter rain. So those are the big things that we are hitting on today. And I want to talk to you about how you can get to taking some action on the ground with the resources that you're stewarding or you're managing. So I mentioned NIACS produced this framework of how to take the broad to the specific. One of the tools that we've developed are a series of menus, adaptation menus, and it's like going to a restaurant and sitting down at a menu and choosing what you're hungry for or what suits your needs best. So we've developed these menus of adaptation actions that you can take, so you can kind of choose what's most relevant to the climate impact that you're concerned about, but also the resource that you're managing. And we have a bunch of different adaptation menus, all on different topics. And the two that I want to highlight and give examples from today are the recreation and the transportation menus in particular. And I have some hard copies of the rec menu at the desk behind us outside in the hallway. But first, I just want to I'm going to orient you to what's on these menus and then take you through some specific examples of national forests in the U.S. who have used these menus to adapt some of their management. So the way the menus are organized they organize different actions you can take along a spectrum. And on one end of the spectrum is resistance, and on the other is transition. So resistance is where you're really trying to reduce impacts, maintain the system or your opportunities the same way, trying to block out climate change. And then transition is where you're maybe promoting change, willing to accept, reduce some risk from future climate impacts. And so resistance, you can think of, I just read an article, out in New York, they're building seawalls in Manhattan to try and block out sea level rise. This is a resistance tactic. We want to maintain what we have here, and we want to block out what's happening with the climate. Resilience is in the middle of the spectrum where you're allowing a little more flexibility. So you're aware of what's happening. Some trends are changing, and you generally want your system or the services you're offering to stay the same, but you're willing to be a little more flexible in how you deliver those services. And then transition. Oftentimes I'm speaking to forest managers, so transition might be something like assisted migration, where you're planting different tree species. That's what that graphic is for, but really you're thinking about changing where you're at to offer something totally different, understanding how the climate is going to affect your area. And so again, these menus are really structured to try and help you get from these big options, we're calling them that spectrum, resistance, resilience, transition, down to some tactics for your site on the ground. And so it goes from this, these kind of categories of 3 options to thinking more about maybe regionally what is happening, some strategies that are pretty big concepts about how you might do climate adaptation. And then there are different approaches listed that get you closer to the on-the-ground level. And I'm going to go through, I want to show you the big strategies that are outlined in the recreation menu. And then I'm going to give 3 specific examples of how national forests have used this menu and the specific tactics, the on-the-ground actions that they decided to use from these menus. So the recreation menu, it has 6 different strategies, and you'll see, as I mentioned, the way those menus are organized is they're organized on that resistance, resilience, transition spectrum. So the first strategy up there is protect and sustain key infrastructure. That is a resistance tactic. You want to maintain things as they are if you can. If you look at number 3, it's kind of in the middle there. That's a resilience tactic where you are managing impacts. Like visitation is shifting maybe because of those shoulder seasons being extended. You're getting more visitors in the shoulder season, so you might want to manage impacts from shifting visitation and use trends. And then you'll see 6 at the bottom is on that transition end of the spectrum where you're going to alter the recreation opportunities that you're currently offering to accommodate expected conditions in the future. So the first example I want to give is from, I mentioned our footprint, it goes from the Midwest down to Missouri and over to the East Coast. And so we worked with the Green Mountain National Forest, which is located in Vermont, and they were working on a resource project that was recreation focused, and they had a lot of different recreation goals. They wanted to maintain their trail network that they had on the forest. They wanted to improve their developed rec sites, and then they also wanted to increase opportunities for backcountry skiing and snowboarding. And I just want to highlight, they did choose to look at a bunch of different tactics from the menu, but I want to highlight the trail network system because they chose kind of a resistance tactic, that more, I don't want to say conservative, but the end of the spectrum where you're trying to maintain your resources as they are. And so the main climate impact that they were worried about on the Green Mountain was more extreme weather events, something Kenny touched on. We're just seeing these more extreme precipitation, specifically in Minnesota. But out there, that was a big concern for them in terms of being able to maintain their trail network. And so they chose a resistance tactic off that menu. The strategy they chose was that first one I mentioned before, where you're really trying to protect and sustain your key infrastructure, the hiking trails in this example. And what they did is there are different approaches nested under those strategies. And the approach they took is they're going to maintain, improve, or construct infrastructure using materials that can withstand a range of climate stressors. And what again, this is where everything we're offering is just a framework because you need to understand your needs and your resource. Their specific action that they chose to do is they were on the fence on what they wanted to do, but they were either going to install a boardwalk in these low-lying areas that were being flooded and inundated where people couldn't pass on the trails. They were either going to install a boardwalk there or they were going to reroute the trail around that forested wetland to improve access and to minimize impacts from hikers on the resource. So that was the specific tactic that the Green Mountain landed on. They're going to build that boardwalk or they're going to reroute the trail. I want to mention that we have those menus available, but I have like the one pager out there, but if you look up the more extended menu, and I have links at the end of the slideshow, we list really specific tactics that might help you brainstorm what you might want to do. So building a boardwalk, rerouting a trail, other tactics that kind of fall into this category are if you're thinking about, extreme heat and trying to reduce heat, just trying to be more sustainable in your infrastructure, you can install green roofs, solar panels. Folks might choose to install permeable pavement to absorb some of that extra water, or if you're worried about flooding, a tactic here could be water repellent heavy-duty tiles that can, in lower levels of buildings, that can withstand some flooding. Okay, here's an example that's a little closer to home, and I should mention this is really in the early planning phases. So if any of you are going to Black River Harbor, you won't see any of this implemented yet, but the Black River Harbor recreation area is in the Upper Peninsula of Michigan. It's right outside of Ironwood. And what they have there is really, the Black River's flown into Lake Superior there. They have amazing waterfalls, trails, trailheads, and they have this, you can see in that upper right photo, they have a recreation area that has some limited facilities there. And so one of the things they wanted to focus on in terms of improving this recreation was they were worried about the increased visitation that they were having on the shoulder seasons, and specifically the number of toilet facilities that they had at the waterfall trailheads. And so the main climate impact that these folks are worried about, it wasn't the increased precipitation like the Vermont people, but the warming temperatures were increasing the shoulder seasons there. And so they were seeing, compared to historical use rates, they were seeing a lot of visitors still coming late into the fall when they were used to shutting operations down kind of at the end of September. And so they chose more of a resilient strategy, so something in the middle of that spectrum I presented. And what they wanted to do was manage impacts from those shifting visitation trends. And the approach they chose was to provide alternate means of access. And what that meant for them, specifically, they were concerned about having toilet facilities available. And the reason there was such a concern is they had a limited number of flush toilets and one pit toilet, but they have a hard deadline of turning off their water on October 1st every year because, even though it's warmer, we still have a chance of frost. They have to shut the water off on October 1st. And so what they chose to do was to install some non-flush toilets that don't depend on a water supply. They're hoping to do that. Of course, it's funding depending. This is in the early stages. But that was the tactic that they kind of came up with, that we're not just going to rely on these water flushing toilets. We want to install more pit toilets. Other tactics related to this approach that we have examples of, that thinking about increased congestion, increased shoulder season use. Perhaps if too many cars are coming and it's late in the season, you could provide shuttle buses to avoid congestion. You could work with local outfitters and guides to incentivize tour operations. So again, maybe people are coming in shuttle vans and they're not all driving their own personal vehicles. Or you can diversify the opportunities. And if you have too much motorized congestion, make a trailhead that's not motorized, just to get rid of that congestion in the first place. And then the last example I want to give, which is on this is one of the most, more extreme ends. This is a transition example, is in Missouri. There's the Red Bluff Recreation Area. This is on the Mark Twain National Forest. And they really had pretty specific needs related to this recreation area. It was located in a floodplain that historically was, not getting flooded, but they were repeatedly getting floods in this Red Bluff recreation area, and it was no longer safe for use. So the main climate impact that they were worried about was the increase in frequency of flood conditions in this area. So they chose both a resilience and transition strategy, and it was to manage recreational opportunities that address the impacts of expected conditions, so just anticipating more flooding than what they had already witnessed. And what they chose to do was recondition their infrastructure located in vulnerable areas. And they did two things to do this. The first was the Red Bluff area was a campsite located in the floodplain. And so they decided to decommission that campsite. They're shutting the campsite down, and they're converting it to a day use area with river access. And so that gave them the ability to not worry about floods flooding out the campers there, and they can also kind of shut off the area with gates if they need to, if the area is flooded. And then they also chose to upgrade and design new restroom facilities that could withstand that flooding. They know it's going to flood. They want to have some restroom facilities there, so they designed that with that flooding in mind. So those are transition tactics that they used. And that's a picture of the campsite, the old campground, flooded. But there are other, that was specific what they chose to do on the ground, but there are other tactics you can do, using this approach. One could be that you could convert, if the roads are no longer safe for vehicle traffic, you convert roads to trails. Maybe you never used to need a bridge on the trail or the road that you had. You could build bridges, or you could improve those bridges to withstand flooding events that you might be experiencing now. And then another thing to consider is if the trees in the area are dying from drought or other climate stressors, you can replant with species that are better adapted to future climates. So that's, thinking about this transition to what we expect future climates, trying to make decisions that allow your areas to be more resilient. So those are a few examples. I guess I mentioned we have this big framework, and I wanted to give you the shortcut method, but basically the formula is you need to understand your climate impacts. Like what is happening that you're most concerned about for your rec site. And Minnesota is so fortunate. We have so much good climate data compared to other states. So Minnesota State Climatology Office, or Kenny Works. We have the Minnesota Climate Adaptation Partnership that Kenny's also advertising on his hat that has really good downscaled climate data. Not every state has that available to us. NIAX has produced ecosystem vulnerability assessments. I have some copies on the table, but this just highlights kind of the trends we're seeing in the area, similar information to what Kenny has presented, focused on forest ecosystems. And then I don't know if folks have visited NOAA's state climate summary pages, but I really like those in terms they just kind of highlight the big things that are happening, and that's for every state in the U.S. So understand your climate impacts. I think a lot of you understand them now after the presentation. And then the next thing you can do is identify what actions you want to take. I mentioned we have the rec menu and the transportation menu. And then help is available. This QR code links to forestadaptation.org, which is a website that NIAX runs. We have on that, a demonstration site webpage, so it has hundreds of different climate adaptation demonstration projects that are nationwide. A lot of them are concentrated in the Great Lakes, so you can look and see what other people have been doing. They're not specific to recreation, but you can filter for recreation. And then the last link that I want to spend just one slide on is this adaptation planning and practices online. So if you follow that QR code and go to the Learn area of the website, NIAX does offer an online training course. It's free, and it will take you through that adaptation workbook, all 5 steps of the workbook. And we just ask anyone to come, bring their own project, and we'll work you through that workbook for your particular project. It's free. It's an 8-week online session, but you're in a cohort, you get coaching, you get feedback, and then you leave with a feasible adaptation plan with those localized specific tactics that are specific to your resource. And registration for that is coming up in December if folks are interested in that. And that's all that I have today. Thanks for listening. Yeah, we have time for questions. Kenny and I both are here.
Hi. Can you speak to the climatic zone that we are currently in? And I've heard things where that's shifting, and we might be getting more of a Iowa-type climatic zone.
Yeah, I don't know if do you want to take the climate?
Hey, thanks for your question. The climate analogs or geographical analogs are a little difficult because they're based on sort of an assumption that the 2 things that matter most are temperature and precipitation. And they, so, and then they're also based on trying to understand what the future climate is going to look like. And, we have to be honest, our sense of the future has changed. Climate models have improved a lot. The projections that they can make have a lot more sort of scientific foundation than they used to because of the computational power. So the earlier climate models from, say, the 2000s often showed Minnesota becoming much drier and then also warmer. And so then when people would reach for the geographic analog, it was Kansas, right? And then more recent models have actually been able to incorporate weather processes into the models and actually incorporate some of the facts of how our climate is driven by weather events. And those models have consistently been showing that actually, this region, basically up the Mississippi and east, is getting generally wetter. And so then the geographic analog is more like, well, depending on the time frame, Illinois, Missouri, Kentucky. It kind of depends on what, Indiana, it kind of depends on when you're looking. But thing is we're never, right now anyway, there isn't any evidence that our relationship with the sun is changing. And so we're going to have, essentially, we're going to continue to have long winters. and we're going to continue to then have, short but kind of bright summers. But that change in sunlight is definitely like that. The facts of the constancy of, available sunlight is going to put a limit on how much we can become like these other places. Right? I mean, aside from the fact that our soil and our bedrock and all those things are different, the changes in sunlight are a major driver, not the only driver, but a major driver of what can live in a place. Temperature and precipitation are very important, but up to a point. And so I always caution, I know it's easy. If you can imagine central Illinois, we're probably going to be more like that in 30, 40, 50 years. But there's a lot of ways that we won't be anything like it. So that's the best I can do for that one. It's a good question. Thank you. Yeah, the question, I'm sorry, the question was basically about what is the geographical comparison to what our climate is becoming like. So you can go. Wait, sure, go ahead, Dave.
So last year was an El Nino year, and it was a nightmare for people who love winter sports. And El Ninos and La Ninas are cyclical. Every time they tell us it's going to be an El Nino year in the future now, should we be freaking out that we're going to have what we had last year, or?
No. The question was, should we freak out every time we hear there's going to be an El Nino because last year's was off the charts? El Nino is a warming of the Pacific Ocean near the equator, especially the eastern Pacific Ocean off the coasts of South America. That would be Peru and Ecuador in particular. And there's kind of this, you could see these maps, there's sort of this long, kind of tongue-shaped warming of the ocean waters in that region. It's about 1,000 miles long and a few hundred miles wide. But that warming is caused by changes in the circulation that drive cold, deep water from the trenches off the coast of Chile and even farther south near Antarctica up the coast and keep cool water off the coasts of Peru and Ecuador. When the circulation changes, the cold water is slower to arrive, which means it has more time to bake in the equatorial sun, and that can then give it some extra heat, and that changes a whole bunch of the dynamics, the working, the kind of operations of the Pacific Ocean, which then affects weather patterns that interact with that region. Surprise, surprise, there are variations in the intensity and the aerial coverage of these El Nino and La Nina events. The one we had last year was fairly strong, meaning there was a big warming, bigger than usual warming in the Pacific Ocean. And typically we don't get nearly that strong of a warming, and it had been basically 27 years since we'd had one of that intensity. So in between we had 6 or 7 other El Nino events. So, and they weren't all as bad as that one. In fact, some of our worst winters have not been El Ninos at all. I mean, in terms of winterless winters, 2011 and 12, which some of you might remember as being similar, very little snow, exceptional warmth, especially in March that year. That was technically a La Nina. So there's a relationship where El Nino tends to give us warm winter without a lot of snow, and that relationship strengthens as the El Nino gets stronger. And there's similarly a relationship where La Nina tends to give us a better winter for recreation. But neither of them are always going to show up, and there tends to be a link between the intensity of either one and the weather that we get. Thanks, Dave. There was a question behind. You had a question.
Yeah, so the question was thinking about how those hardiness zones are shifting and warmer, wetter, thinking about forest tree species and what we recommend, or what would we recommend. I didn't put a link to it here because I wasn't sure if this crowd would be interested, but there is a really powerful tool called the Climate Change Tree Atlas. And it's researchers from the Forest Service who have looked at 125 different tree species in the eastern U.S., so Minnesota all the way down to the Gulf Coast and east. And they have modeled, they've looked at, they look at the current range, and then they model the future potential suitable habitat for those species. So looking at how their ranges might shift or whether or not they're, predicted to increase or decline in abundance, given what we know about climate and given their current adaptability. It's based on several models and then literature reviews. But it's hard, it's hard to just give a recommendation because so much depends on the site. It depends, there's a lot of nuance in that. So we have some really good data. I will say, topic, Kelly, poor Kelly, who's here, I talk about I'm on a team within the Forest Service that's looking at assisted migration. And Kelly's seen that presentation 10 times probably, because it's a topic people are really interested in right now. And the Forest Service is probably a little behind the curve in thinking about it. And we're in the process of updating our policies to allow for assisted migration of tree species. But one of the main approaches that we're promoting, and that a lot of people here should, I think, hear the message, a really safe bet that's not that risky, because we don't want to introduce some invasive species or take something so far out of its range that it's not adapted to our current ecosystem. Because you usually talk about throwback winters. We didn't mention it in this one, but we still, even though we're on this warming trend, you saw the zigzag lines, we're going to get cold winters still. And so you don't want to introduce a species that can't handle that. A really safe thing people can do if they're thinking about planting trees right now is you can plant the same species, but you can get your seed from a seed zone south. Go 60 to 100 miles south to get your seed instead of collecting it locally, and plant that seed instead. But it is something that forest managers are thinking about, just getting seed further south, or maybe taking something that's very close to its range edge and moving it northward a little bit, or even if there are species that are rare on the landscape. I'm not sure what part of Minnesota you're in, but I'm in northeastern Minnesota, so some of the oak species are projected to do well with climate change. They're not very abundant in northeastern Minnesota right now, but they are present, and they're projected to do well. So you may, consider planting more of them on the landscape given the site conditions. But the Tree Atlas is a really good resource if you're interested in that information. I'm going to go for an audience member before.
So have you done the climate adaptation workshop that you did? Either of you, can you speak?
Oh, I facilitate. I lead those sessions. So, I don't tend to do the online version. I usually do in-person sessions with people. So, I'll travel to different areas like those national forests I mentioned and lead them through it in person, which is usually a few days. But the 8-week session, it's just I don't even remember if it's every week. I think it's a weekly session, and then you have small amounts of homework in between. But it takes you through each of those steps where you identify the goals, you look at climate impact specific to your region, you make sure your goals are still reasonable given what you know about climate, and then you brainstorm those adaptation actions, which is really using those menus as a guide to get site-specific things you can do for your resource. And then there's a bit about monitoring to think about how you're going to understand if what you did was effective.
And then the follow-up to that would be are you guys at all affiliated with getting electrical grid more off of coal, or just in general, that is not USDA Forest Service at all, right?
Well, you want to? Oh, yes. I'm sorry. The question was about the adaptation planning and practices online and facilitating that. And then there's a follow-up question about if the Forest Service is about getting off the grid or reducing coal. We do have a sustainable operations plan, the agency level, at the Washington office, the Forest Service does. And they're it's actually a relatively new plan, and they're trying to implement like a trickle down. So there's 2 national forests in Minnesota, the Chippewa and the Superior. We get that trickle down information where, thinking about what you can do locally, like converting the fleet to electric vehicles or something like that, installing solar panels. It really depends on what we have available to us, what resources we have, but there is an initiative within the Forest Service looking at that.
Comment on that real quick,
Yeah.
too. Just a little story time about adaptation in general. In the 2000s, late 90s and 2000s, that there wasn't much of a talk of climate change. It was global warming was the term at the time, and it was getting beat up pretty good. And the policies that were being recommended were related to coal and oil. Got to stop burning coal and stop burning oil. And one of the major tactics of the I'd say the movement that was opposed to climate change science at the time was to de-emphasize mitigation, which is what you're describing, and emphasize adaptation. And adaptation became this kind of dirty word amongst people who accepted the science of what was then climate science, because it was sort of a signal that you weren't actually about reducing greenhouse gas emissions. You were just about adjusting to the problems that we were causing with them. And that actually took a huge bite out of our collective ability to adapt, which is actually an urgent issue because the climate is and has been changing, and that is changing the context in which we work and live. And so we actually lost a lot of ground for maybe a decade, where there wasn't a tremendous amount of adaptation work being done, and there also was almost no mitigation work being done. So that was great. So one of the reasons that some of the organizations really focus specifically on adaptation and actually distinguish between adaptation and mitigation is because it's urgently needed, and it's actually been underserved. There isn't enough of it. Things that Katie was describing are really, really hard. Site-specific types of information that you need. It's really kind of a massive undertaking just to adapt to the climate we already have, let alone the one that's coming. And so it is, in many cases, more than even we can do just to focus on adaptation. So I just thought I would throw that in there. It's one of the reasons we talk about it so much now. It's badly needed. So I think we have a minute left, so we can take one more question.
And then there's a survey, I forget.
Oh, yes, and there's a survey that you need to,
For the event, if you.
for the
have
event,
that.
or for the, oh, gosh.
Okay.
Sure,
But I told you that earlier.
yeah. Go ahead.
Projecting that we may end up closer to like central Illinois, you said between 30, 40, 50 years. So I'm part of a trail organization, so those increasing floods and also storms and things like that are kind of a big challenge for us when they bring all those trees down. What's going to happen to the forest in the interim? I mean, the fear speaking is, is there going to be like mass die-offs of plants up here, or what's going to happen to the forest before it kind of adapts to the new climate that's coming?
Yeah, so the question is, what is going to happen to the forest in the interim as the climate is warming, and is there going to be massive die-off? And I would say it's not going to all happen at once. Northeastern Minnesota, your Superior Hiking Trail, like northeastern Minnesota is actually really, even though it's warming the fastest, it does have a lot of resiliency in it. If you look at different ways to model that and imagine that, we do have hope on this landscape for in our cool, slopes and low-lying areas, maybe close to the lake, getting buffered from some of these extremes. We do have hope to have some refugia areas for these boreal conifers that we can likely retain them on the landscape for a while. The thing is, we do need to start thinking in the terms of assisted migration, like maybe not moving out all the tree species, but at least getting climate adapted tree climate adapted seed for the trees that live and the species that live in this area right now. I think the biggest, when you might see massive die-off, is if we have drought, if we have, something that is newer in Minnesota are invasive insects that we used to be able to ward off with our extreme colds, and the fact that winters are getting warmer, there are more invasive insects that are affecting the trees that live here. And so if you have die-off from an invasive insect, and then you have a drought, and then you have a massive wildfire, I mean, that's where we're going to see massive die-off. It's from the compounding of all these different stressors. But we have, I showed this adaptation menu for rec. We have adaptation menus. We work with National Forest to think about, and other organizations to think about what we can do, planting a diversity of species, getting your seed from further south. So, I wouldn't be doing this work if I thought it was hopeless. I don't think Kenny would be either. Like, we don't just want to throw up our hands. And so we can do things proactively, but we have to be thinking about that, and we have to be taking the actions.